Okay, so please, as I said in the actual video for the whole class, try not to get confused with the A and B for being our variables here, but I could totally understand why you do. All right, and don't forget also I brought in from the previous exercise, that is the definition of a general solution for a Diophantine equation, okay? So once again, in this case, B, okay, let's write this down. In this case, like as far as the general solution is, B will equal 6 and A will equal 22. And also I know D, hopefully you can see that 22 is 11 times 2. So D will equal 2 from that. But anyhow, that's from that one. But let's just use the algebra they got here, okay? Otherwise, I don't know how confused we're going to get. Right, so the way you use the Euclidean algorithm to find the solutions for the Diophantine equation is first you just go through with the 6 and the 2, or 22. So we start off with 22. It's equal to 3 times 6, 18 plus 4, and so 6 is equal to 1 times 4 plus 2, and 4 is equal to 2 times 2 plus 0. Okay, so the note there also is, so you can definitely see that 2 is there. So highest common factor of 22 and 6 is equal to 2, but that's another story. But let's go backwards. Okay, so if I'm going to look at this equation here, so I'm going to call this one, so this is 1, 2, so on and so forth, and 3 is our final one. So because of the 2, because the reason I'm using that is because this finishes with a 2, right? Okay, so 2, so from equation 2, we've got, if you just rearrange it, 2 is equal to 6 minus 1 times 4. Okay, and then we can go up to the previous equation. So that's equal to 6 minus 1 times, which is not a really interesting to do, right? But and so I'll just put this, so I can rearrange 4 is equal to 22 minus 3 times 6. Okay, so this is equal to 22 minus, so 1 times, don't need the 1 there, 3, stop being annoying, 3 times 6. And so another way of saying 6 is 1 times 6. So now I can so subtract the subtraction. So that will become 4 times 6 minus 1 times 22. Okay, so I can see now, if we go back to what we wanted here, we're looking at 22 times A and 6 times B. So if I had A was equal to minus 1, okay, because I'm looking at this number here, and B equal to 4, then 22 times minus 1 plus 6, so that's A and B, times 4 will equal 2. So that means that minus 1 and 4 is a solution. Okay, is a solution of this Diophantine equation. And let's go back up here. So the general solution, let's not forget, is so from now on all A's, so annoying, is going to equal A naught. Okay, so A naught will be minus 1. I don't know what to call this number now. Anyhow, plus the other number 6 plus 6 on 2 is 3 times t, and the solutions for b will equal b naught minus 11, because it's 22 on 2, times t. Is that right? And so if we sub back in our numbers, okay, so that means that our general solutions, generals are there, solutions are, a is going to equal, so a naught, what was that again, minus 1 plus 3 times t for, and b will equal 4 minus 11t, and obviously t's in the integers, and so you've got infinite solutions that way. All right, so hopefully it was clear that I went through the Euclidean algorithm and then I just used it backwards. So I used it by rearranging different values for, obviously these were my remainders here, and these were my a's, so to speak, and that's the quotients there. And what color should I use? And that was my, I already used B, green. So I got yellow there. All right, okay. Good luck. We're gonna do this again. The next example is a little bit more involved.